there was a problem with the audio. Is it working now? So I assume you didn't hear anything from the beginning. Do I start? Yes? Okay, it was just cut. Okay, only the agenda. Okay, good. So I restart for the agenda for today. We will first go through an introduction about the aircraft applicability for this webinar. Then we will introduce the GNSS interference concept, jamming and spoofing. We will go through current context and related recent official international publications. After this, we will go deeper into details on the GNSS interference with an explanation of the possible cockpit effects. We will go through the known system misbehaviors and operational considerations. In the third session, we will make a focus on GNSS spoofing with a detailed explanation of the threat, possible cockpit effects, and operational considerations. In the fourth session, we will make a focus on undue alerts. There will be also a dedicated webinar beginning of next year. So let's go into the subject. GNSS interference is a disturbance that affects the normal reception and use of the GNSS signal. What different types of GNSS interference we may have? First of all, we need to recall that satellite navigation signals are quite weak. Radio frequency signals present in the GNSS frequency band can degrade the GNSS reception capability by increasing the noise. This is what we call GNSS jamming. The effect of GNSS jamming is a degradation of the GNSS signal that can lead to a partial or total loss of the GNSS data. This is a well-known threat present for years. Many of you have already been very familiar with these effects. On the other hand, we may have a fake signal that aims at replacing the real one to deceive the GNSS receiver. This is what we call GNSS spoofing. Spoofing may lead to inconsistent or erroneous data. It shall be highlighted that a spoofing threat may have most of the times the same effect as jamming at receiver level, and only if the receiver is indeed deceived, we can get inconsistent or erroneous GNSS data. Airbus has been working on spoofing characterization for several years now. In-service observations confirm that the spoofing threat has lately been increasing significantly in different regions of the world, and we can say now that it is a confirmed threat in aviation. As mentioned before, GNSS interference is increasing over the years. 2022 and 2023 shows a further increase of the threat, mainly due to the geopolitical context, mainly in geographical areas that are surrounding conflict zones. Even further increase is observed since September 2023, with increasing reports which spoofing is suspected. According to the EASA, which matches Airbus observations, the main affected areas would be the Black Sea area, the South and Eastern Mediterranean Sea area, and the Middle East, and also the Baltic Sea and Arctic area would be affected. To illustrate the trend, we can see here a map of the evolution of the interference threat of the years according to the anonymized data received from our Skywise customers. International regulatory organizations are very active on the subject with the recent publication of recommendations from EASA Safety Information Bulletin that was updated beginning of November. Also, the DGCA released an advisory circular on the subject with recommendation. It is to be noted also that the FAA did also a communication about spoofing without official publications. And finally, the IATA published in September 2023 guidance and recommendations for GNSS radio frequency interference safety risk assessment. So now let's go deeper into details of the GNSS interference effect on Airbus aircraft. First of all, I'd like to show you with a high-level overview of the GNSS users in GNSS hybrid navigation architecture. The goal here is to illustrate which kind of GNSS inputs are used by the different functions to better understand the cockpit effects. It is important to highlight that this is a simplified version of the architecture that is not exhaustive and is just for the explanation purpose. At the upper side of the slide, you can see the GNSS receiver that computes the GNSS data. Then we have the users. For instance, regarding navigation, the aircraft position does not use pure GNSS position from the GNSS receiver. It will use the best accuracy solution from the different inputs, which are GPRS position, IRS position, or mixed IRS-NAVEX position. Then, when we go to the surveillance functions, we can see here that functions such as post-predictive modes or ADS-B use pure GNSS position as a primary source. Also, GNSS pure input is used by the time reference of the aircraft, and this time reference is used for the FMS prediction for applications such as FMS predictions, ADS-C, or CPDLC. In this slide here, we can see that there is some aircrafts that use for the ADS-B the GPRS information as an input. This is just for your reference. During the presentation, for the sake of clarity and simplicity, this connection will not be shown. So here we have the main cockpit effects that would result from a GNSS signal partial or total loss. Regarding navigation, GPS or GNSS could be lost. We could also lose the GNSS-based navigation with the message on ND, GPS primary loss of NAV primary lost. Optional features such as RMPAR, GLS, SLS, or airport navigation functions could also be lost. Regarding surveillance, GNSS degradation will result in the loss of ADS-B out and int functions. Predictive thoughts could also be lost, and optional features such as ROPS PTB could be lost. Weather radar ground declutter could be degraded. Other effects that have been observed under GNSS interference that could result from inconsistent GNSS data are navigation, such as nav FMS position disagree. It's important to highlight that this one is not only linked to GNSS inconsistent data. We could also have it with FMS degraded position, for instance. We could also have inconsistent wind speed and direction on ND. And regarding surveillance, we could have anti-UTOS alert, terrain display shift on ND, TOS faults, TCAS and predictive wind shear faults for A380 and A350, and inconsistent aircraft time and FMS predictions. Such events are not expected to occur in case of GPS total loss. Please report inconsistent information to Airbus to allow analysis and follow-up of the event. One may think that inconsistent information is linked to GPS spoofing, what we will see afterwards. However, it's not necessarily the case. It could also come from transient computer inconsistent information under GNSS interference. Analysis needs to be done. These effects are expected to be temporary and expected to be clear after leaving the affected area. The full list of cockpit effects is available in the ISI 3436-49 and also in the FCOM that is customized by each aircraft. I mentioned before that the effects are expected to be temporary and disappear after leaving the interference area. However, we know there are some system misbehaviors that do not behave this way. We will go through 3 different misbehaviors here. First of all, we have the MMR GLU 925 that could be locked after radio frequency interference exposure. Actually, the GPS card could be locked in degraded mode until MMR reset on ground. This can result either in the detected lock of the GPS with main effects nav GPS fault or GNSS fault depending on the aircraft type, and if both MMRs are affected, this could lead to GPS primary loss or nav primary loss on DND. There is also the possibility for the receiver to be in an undetected lock. If both MMRs are affected, the ADSB out function will be lost till the end of the flight. Also, GLS, FLS, and SLS deviation might not be available with or without ECAM alert. As a mitigation, we have for the A320 family a NIM flight reset that could be done, that is currently included in the FCOM reset table of the recently released FCOM November revision. It is to be noted that for the other programs, the circuit breaker is not available in the cockpit. Please note there is currently a study to maybe include a cockpit circuit breaker, in the A380 family. Depending on the study outputs, it could be considered for other aircraft types. For this issue, we have an enhancement of the MMR that is the new GLU 2100 that is not affected by this issue and is currently available. Then we have an issue about the electrical clock that could drift if set in GPS mode during the GPS signal degradation. The clock time is expected to get back to normal when the GPS input is recovered after leaving the GNSS interference area. However, if combined with previous effect, the clock drift with the clock in GPS mode could last till the end of the flight. Which are the consequences? Consequences could be erroneous time information in FMS predictions and ADS-C and CPDLC capability loss, as the requirements of the time precision of 1 second is not longer met. As a mitigation, we propose switching the clock to INT mode before entering the GNSS interference area, which prevents this issue from happening. This mitigation is available today in the FCOM Supplementary Procedures GPS Interference. There is already corrective clocks available. The correction, what it does, is that the clock goes automatically to INT mode under GNSS GPS degradation, even in GPS mode. The third one that could be maybe a new one for many of you is an issue recently found out with the ADRU A350 that could be latched in coasting mode prior to long exposure to radio frequency interference. For your information, the TFU has just been released, so you should be receiving it, or you should have it available already or receiving it shortly. The description of this issue is that when the GPS data are lost during more than 1 hour, the ADRU latches the coasted mode until the end of the flight. Which are the operational consequences? We can have, regarding navigation, the loss of nav primary until the end of the flight. And for the surveillance, we could have the ADSB out capability lost until the end of the flight. As mitigation, depending on the navigation and surveillance requirements along the affected routes, flight planning could be adapted to avoid 1 hour exposure to GNSS interference, even if we know that in many cases for some customers this is not easy. The terminating action is the ADRU S8, for which certification is expected at the end of 2025. This is in progress. Then we have Airbus is receiving few reports from airlines with cockpit effects that are not currently listed in the ISI or TFUs, or cockpit effects that not fully correspond to current understanding on the impacts. We would like to inform you that analysis is currently ongoing. If the analysis confirms a link with GNSS interference, the new effects will be included in the ISI and then also in the FCOM. Analysis of the mitigations will be performed, and FCOM procedures will be adapted if considered relevant. Corrective actions will be launched if applicable. We recommend contacting Airbus for even analysis in case of suspected abnormal cockpit effects related to GNSS interference. Your inputs are really valuable for us, for the threat understanding. Then we go through the operational considerations for A320, A330, A340, A380, and A350. So first, for the during flight preparation, review and consider NOTAMs related to known or expected GNSS interference. In case of NOTAM, either authorities 1 or airline 1, review non-GNSS based routes and approaches, such as ILS, VOR, or DME. During preliminary cockpit preparation, complete IRS alignment if the flight crew expects long segments with low radio navigation coverage. During flight, the loss of GNSS is expected to be detected by the system, which indicates a loss of capability. Indications are provided on ECAM displays or navigation displays. Follow FCOM normal or abnormal procedures as required. There is no need to deselect the GPS unless requested by the procedure. Set the clock to int or manual in A350 before the interference area and back to GPS or auto in A350 after leaving the interference area. Notify the ATC of a loss of GNSS signal and relevant capability degradations such as ADS-B out, ADS-C, RMP, etc. On ground, report possible GPS interference and associated cockpit effects. You can refer to your FCOM supplementary procedures, GPS, GNSS interference. And there's a slide covering the A220 family. The A220 team is actively investigating the effects of GNSS interference. The architecture differs, so different effects are expected. The A220 team published a first version of the A4T, similar to the in-service information from legacy aircraft. The analysis of the new effects and mitigations is ongoing. A new revision of the A4T is expected early next year to provide new validated cockpit effects and potential mitigations. A GNSS interference webinar dedicated to A220 is scheduled in February, as indicated in the last revision of the A4T. So let's move now to the GNSS spoofing section. I believe that many of you might be interested in this one. I let the floor to Laurent Azoulay, Senior Navigation Expert. So please, Laurent.
Thank you very much, Laura. Good morning and good afternoon, everyone. I'm Laurent Azoulay, Senior Expert Navigation, and I'm pleased to be with you to support you with respect to the matter of GNSS interference. So GNSS spoofing is a different animal. As you can see, with a correct position, latitude, longitude, and UTC time, unfortunately, GNSS spoofing can affect this data to become erroneous. And so I will explain in a few slides how it works and how it affects GNSS-based information. So back to the basics. As you know, Airbus aircraft are fitted with two multimode receivers that embeds GPS receiver, and this GPS receiver is able to acquire and receive signals from GPS satellite, so the US GPS SatNav constellation. Also augmentation from the Airbus geostationary satellite to have an augmented position on GPS to perform the SLS function, and also GBAS capability that is relying on a GBAS ground station at airport to provide the GLS function. GBAS station provide corrections for augmentation through a VHF data link. So the case of GNSS spoofing is the fact that an emitter will provide GNSS-like signals that are replacing the authentic signal, and this replacement will mislead receiver and could possibly generate erroneous outputs. The spoofing depends on receiver susceptibility, so capacity of the receiver to receive the signal from the ground instead of the GPS satellite signal, and inability to monitor and to reject this signal, and also due to the spoof signal properties that can be due to strong power, alignment, proper alignment with authentic signal in code phase, and Doppler frequency. Usually what happens is that a spoofing signal intervenes after a jamming has occurred, because the jamming will make the receiver lose the signal, and then the fake signal from the spoofing emitter will replace the authentic signals. So let's illustrate the three types of spoofing case that we can encounter. The first one that is well known by maintenance operators is the GNSS repeater. Basically, the idea is to propagate a real GNSS signal from the satellites inside a hangar, usually maintenance hangar or factory hangar. The objective is to use this signal in a hangar because it actually masks the signal, to be able to do some testing, for instance. So this is something that is often found in the United States, for example, but in France it's forbidden, and in Germany you can obtain that, but you need a license to provide these signals. So this is the kind of event that can be encountered with a misuse of a GNSS repeater, and we have seen some cases happening from laboratories doing experiments using a GNSS repeater. The second case is what we call collateral spoofing. So basically the idea is to generate spoofing emission with a synthetically generated GNSS-like signal, but the objective is to spoof a given target without affecting the other receiver. So basically, this is the kind of spoofing we are often seeing now, that we believe we are seeing close to conflict zone, where the local army, the local government or organization are generating this signal to protect sensitive sites. And so as a collateral victim, all the receiver in the vicinity will receive this signal, and this signal will basically say that instead of being with your aircraft location, you will be at a static location far from the sensitive site. We believe that all the recent cases observed close to conflict zones in terms of spoofing were collateral spoofing. And the third case that is more sophisticated and more malicious is what we call the targeted spoofing. So this requires heavily sophisticated instruments, a capability to track very accurately the victim location. And so the idea is to track the victim and to provide really identical signal, but with a displacement to really spoof the position of the victim. So for this case, we have a strong belief and evidence also confirmed by the FAA, for instance, that this has not been observed so far, that civilian aircraft have been targeted. So now let's have a look at how this kind of threats propagate through Airbus GNSS hybrid navigation architecture. As a reminder, as explained by Laura, the aircraft position that is used for guidance of the aircraft is a selection among three possibilities. One is the combination of GPS and IRS measurement in a tightly coupled optimal filter. This gives the best performance and enable to perform RNP operation, for instance. If the performance of this solution is not good enough, there is a possibility to switch to IRS combined with DME measurement or IRS VOR DME measurement. And finally, if you don't have capability to receive GPS or DME or VOR, you will switch to a pure IRS position. So the important information here is that there's no possibility, this is not how it's constructed, that you use a pure GNSS position in this type of architecture. So now next one, please. So we'll see that looking at the architecture, you can see that the GNSS receiver measurement goes into the inertial system, and we have two independent inertial-based information that goes out from the inertia. One is GPIRS, and in case the GPIRS position is affected by GNSS spoofing, then the GPIRS position will be able to reject the GPS measurement and switch to coasting. And at not any time, the pure IRS position will be affected by the GNSS spoofing. So there's no possibility that there is a pollution of the GNSS spoofed to the pure inertial information. So let's see in the next slide the illustration, what happens as a reminder. So the aircraft position is based on GPIRS or IRS DME or VOR or pure IRS. We compute the combination, hybridization of GPS and inertia, and so far observed in service and confirmed by also lab test, the cases of spoofing that we have encountered, that our customer operators have encountered in the field, are only either GNSS repeater or collateral spoofing, but never civilian aircraft attacked by targeted spoofing. So in this case, the performance of the ADIRs combining GPS inertia have always rejected the fake GPS measurement from a spoofer. And so, for this reason, as indicated by Laura, the GPS depth selection is not required. Obviously, we are monitoring the situation. We are getting also your report, and the situation may evolve. And so we will adapt our recommendation according to in-service observations. Thank you, Laura.
It's okay, Fernando. So thank you very much, Laurent, for your clear explanations. Now I get back to our block diagrams to illustrate the possible impact of the GNSS spoofing. As in previous one, this is not exhaustive and is just for the explanation purpose. It shall be highlighted again that the spoofing threat may have most of the times the same effect as jamming at receiver level. So only if the receiver is indeed deceived, we will get erroneous or inconsistent data. As very well explained by Laurent, an erroneous or inconsistent GPS position is not expected to affect the aircraft position. Actually, the inertial system acts as a barrier with the ADIRs switching to coasted mode. But as you can see here, an inconsistent GNSS position can go through the surveillance system, and the TOS predictive modes and the ADSB functions will use it. The actual possible effects of the inconsistent pure GNSS position are regarding navigation, GPS primary loss or nav primary loss. Also, we may have nav FMS GPS position disagree. The crew could see that the GPS position and the FMGC position in the monitor page of the MCDU differ or MFD. Regarding surveillance, we could have undue toss alerts. Also, we could have terrain display shift on ND. I'd like to make us focus on this one, as we believe that it has been observed by many of you flying in the East Mediterranean Sea or Middle East. Sometimes this effect could be misinterpreted as a map shift. However, the aircraft position is not affected. It is only the terrain layer display on ND that does not actually correspond to the real aircraft location. In this ND figure on the right, for instance, we see that the aircraft is flying over an area over the sea in blue, when suddenly a spurious toss alert raises, an erroneous terrain thread appears on the ND. This can happen in case of erroneous pure GNSS lateral information, so latitude or longitude, showing the terrain of another lateral location instead, or in the vertical plane, showing the terrain as much closer to the actual terrain due to low GNSS altitude. Also related to inconsistent low GNSS altitude, the toss function could be temporarily lost, and also the TCAS unpredictable wind shear on A380 or A350 aircraft. Another possible effect on surveillance is the erroneous transmission of position data via ADS-B out, but this will be transparent for the crew. Then, if we go to inconsistent time impacts possibility, the GNSS receiver may compute if deceived by spoofing inconsistent GNSS time that may affect the aircraft time reference. Its effect, it could be observed and affect the FMS prediction, ADS-C, and CPDLC functions. Here we can have inconsistent time, CPDLC and ADS-C capability lost, and inconsistent time in FMS predictions. Once again, the same that for the general cockpit effects in interference, the effects are expected to be clear when leaving the affected area. Which are the operational considerations regarding spoofing? There's no need for the crew to distinguish between GNSS spoofing and GNSS jamming. The same procedure as the GNSS interference apply, which is available today in the FCOM. Implementary procedures. So follow ECAM and FCOM procedures. GPS deselection is not required unless requested by the procedure. Please note that GPS deselection impacts only the aircraft position used for navigation, and it has no impact on other users such as communications or surveillance. Before entering the interference areas, set the clock to int mode or manual mode depending on your aircraft type to prevent aircraft time corruption. Then, operators' reports are essential for Airbus to monitor the situation and study mitigation measures. You can refer to the ISI section 3 for the necessary data that may assist in the analysis of the event. Now, in the following section, we will make a focus on the undue toss alerts under GNSS interferences. We are receiving a significantly increasing number of event reports from operators. Last year, a deep analysis was performed to evaluate the possibility to modify the FCOM abnormal procedures for the toss warning memory item to address some obvious situations such as daylight VMC with no terrain threat or high cruise altitude. Our conclusion was that Airbus, as an aircraft manufacturer, provides in the FCOM a directive procedure related to the toss warning that defines how the crew has to react to a real terrain threat. Airbus does not intend to introduce any delay by the introduction of conditions in the application of the toss warning procedure. There's no time margin to analyze the context of the alert in case of a genuine alert. This being said, we cannot deny the existence of a real operational problem and the need to support airlines in the challenging context of increasing number of undue toss alerts. that are mainly linked to GNSS RFI given the geopolitical context. Several operators are asking us for guidelines on undue tows. While we don't intend to introduce delay in the application of the warning procedure, we acknowledge the airline need for adaptation in case of recurrent exposure to undue tows alerts. For this, airlines are in the best position to perform an ad hoc safety assessment using their knowledge of the operational context. For example, the departure, cruise and approach operations, lateral, vertical positions, cold weather operations, clear knowledge of the environmental conditions and the terrain conditions, to clearly identify areas within the routes where tows alert can only be undue without any risk of genuine terrain or obstacle threat. This assessment may allow the operators to define guidelines and brief the pilots on how to address expected undue tows linked to GNSS interference, such as potentially disregard an anticipated undue alert. The goal on this one would be to prepare the crew to potential undue alert at the specific areas. Briefing will identify the situation where an alert can only be undue without any real risk of threat. This can avoid making decisions during flight that can result in a delay in procedure application for genuine alerts. Another possibility is the temporary inhibition of the tows predictive modes using the TERR push button switch to off over areas where predictive undue tows alerts are expected to be recurrent. For your information, these operational considerations are today available in the ISI 343649, section 2.2. Airbus will support airlines by giving design specificities in the ISI article to help the assessment and guidelines definition. Here, would like to share with you some consideration that should be taken into account when considering the predictive mode inhibitions. Predictive tows are a safety net, so deactivation of the terrain modes implies a deactivation of a safety net, which requires a procedure ensuring the reactivation after leaving the affected area. Also, this can lead to an increased risk of more true nuisance alerts at certain locations, for example, as in the figures below, for approaches on which we have a cliff or mountain along the approach path. Then, to recall you that the inhibition of the TOW's GPWS predictive modes must not be based on flight crew judgment only, but shall be briefed before the flight. Other design specificities to be taken into account is that the GPS deselection only impacts the navigation position. It has no effect on tows. Also, GPWS basic modes do not use GNSS-based input. Now we are getting to the end of the presentation. I'll hand over to Captain Gilbert Savary, Head of Flight Operations and Training Policies, for the latest section, conclusions and way forward.
Thanks, Laura and Laurent, for this detailed presentation. And it's time to conclude and also to look the way forward, because as you understood, GNSS interference is a threat that is active and evolving and increasing in sophistication. And with all the reports we receive, all the contact we have with you operators, we fully understand at Airbus level that it's a huge operational burden and a potential safety impact. So as a manufacturer, we're working, of course, on aircraft system. So first, as explained, we have some corrective for non-misbehavior. We have some material available. Certification is available or ongoing. So on our side, we're pushing hard our suppliers to decrease the delay for ongoing certification to make those technical solutions available for you as soon as possible. Of course, we have some feasibility studies ongoing to improve GNSS interference awareness, also to improve the resilience to GNSS interference. If new system issue is confirmed, of course, we will analyze and provide corrective or mitigations. We know that on aircraft system it can take time, and in the meantime, the flight ops mitigations is important, and we receive many requests from new operators, and we know your expectations are high. So yes, we have some procedures and recommendation already available in FCOM, also in the famous EASY article 343649. If new cockpit effects are confirmed, we will put this input in the EASY and in the FCOM. Analysis of mitigations will come with an FCOM update if relevant. We use the EASY first just for you to provide with information as soon as possible, and we do not depend of FCOM revision cycle of your airline. So EASY is to go fast, but our goal is also when consolidate any mitigations, any operational mitigations, any recommendations, or any procedure will be added in FCOM PROSIP. The communication, VFOT is part of will be provided to you following this webinar, and EASY again is one of the most convenient and efficient channel to deal with this situation and to contact operators. So remaining, of course, your operator feedback is very important to collect and we collect and analyze. At the Airbus level, we reinforce the team to deal with these occurrences and to be faster in terms of analyzing and understanding what happened. And so it's a continuous monitors in service feedback. Reports are very important and essential for us, and as it's evolving, and as we mentioned, we need a complete technical understanding of the effect and operational impact to be able to define evolution of a system or procedures or recommendations. Laurent perhaps will explain, but we have a lot of work on progress with authorities, and as this issue, of course, is a global issue and that needs to be addressed at industry-wide level. So we are actively involved in this relevant forum for evolution of regulation, the standards, and also the recommended practices. So now I think it's time for the Q&A. We already received many questions, so I will propose to let you 5 more minutes to fill in the Q&A, and then we will give you some answers. Thank you.
Okay. I think we will start with the Q&A. The first question that we received was about the GPS card. Why does GPS card lock occur? Laurent, if you want to answer.
Yes, thank you. So yeah, the GPS card lock occurs due to a GNSS interference in terms of emission levels, which are out of certification standard. And as a result, and there's an inability of the GPS card inside the multimodal receiver to reset and to restart upon the recovery of GPS signal.
Thank you, Laurent. The next one is about the in-service data. Does Airbus have data in-service results for GLU 2100 over flying Ankara and Iraqi FIR? Who wants to take this one? Laura?
So, according to the in-service feedback, we have no reports regarding specific issues related to GLU 2100. This is expected to be fully recovered after RFI exposure.
Thank you. The next one is regarding the monitor retrofit. Given the well-known and documented history of the GLU 925 lockup, will Airbus consider monitored retrofit service bulletin for upgrades to the 2100?
So, as of today, a monitor retrofit is not planned for the MMR. So I can. Yes.
Apparently there is mic issues. Ah, okay.
Yes.
Do I need to repeat this one? Okay. So referring to the FAIR 23.0249, from fellow airlines reports, we cannot say that the GLU 2100 MMRs show better protection against GPS interference in radio frequencies area. What is Airbus' view on this?
So for the time being, what we can say is that the GLU 2100 is not affected by the lockup issue, which is described for the 925. However, it's still susceptible to the general impacts of the GNSS RFI. It is, yes, expected to be more robust against certain problems observed in previous MMRs, but it will, of course, be lost during GNSS exposure, temporary.
Thank you, Laura. Another question is when Airbus will have a fix to this issue? Or if you want to take it.
Yes. Well, you know, as we explained, the GNSS interference threat remains a continuously evolving threat. And so we are looking at and studying all the improvements that we can propose, whether it is operational improvement, procedural improvement, or system improvement with respect to all reported effects. So we take all reported effects and we look at them and how we can mitigate them. For the longer term fix of the issue, and since it's an evolving threat, we are working with the industry, so aircraft and avionics manufacturer, the ICAO organization, IATA, for instance, airworthiness authorities and air navigation service providers to reduce as much as possible the occurrence and the effects due to GNSS interference.
Thank you, Laurent. The next question is, why does one spoofing source affect GPS 1 and 2 outputs differently on the same aircraft event?
Yes, so to give a little bit of explanation, so we have two GPS receivers and two multimode receivers, and they are totally independent to each other. And so they may, since they are not synchronized and not connecting to each other, they may receive different GPS satellites. And it's even more the case when now we have a lot of GPS satellites in the sky. So the spoofing source may affect different satellites, not necessarily all GPS satellite signals. And the two GPS antennas are differently located, even if close to each other. So they may, the spoofer may affect, may not affect similarly the two GPS receivers that may have a different behavior because it's not the same threat and not the same GPS satellite affected.
You. The next question is, has there been known cases of GNSS spoofing on Airbus aircraft, and what has been the effect on the aircraft?
So the answer is yes. As we mentioned before, we have analyzed cases that answer to a spoofing signature. The different effects we have observed is those that we have been through during the presentation. So undue TERS alerts, or for instance, the nav FM GPS position disagree, or the result of low GPS altitude with the temporary loss of the GPWS basic modes, TCAS, and predictive wind shear.
Thank you, Laura. Next one, do you have any information of non-state actors carrying out collateral spoofing? I think I can answer this one. At this stage, no, we don't have such information. For the next one, how does the system recognize that it is being spoofed to revert from GPS to DME-based position?
So, and I will combine this answer to also the next question, which is what is the basis of rejecting of the spoofed GPS signal, which comes from the same person. So the spoofing is a very complex, let's say, activity for the one who wants to spoof. And to be successful, it must maintain a very high quality and performance of GPS signal. As indicated earlier in the presentation, it must respect some requirements in terms of code phase, synchronization, alignment with the real GPS signal to be detected as authentic. So the ideas to combine GPS and inertia have various quality checks and performance checks with respect to the GPS satellite signals. And so the GPS satellite signal must respect some ICAO standards in terms of performance. And so far, the ADIRS quality checks have succeeded in identifying that the performance of the fake GPS signal were not meeting ICAO standard. Therefore, the ADIRS has been able to reject the fake GPS signal, and that's upon that rejection that the ADIRS start to perform what we call the inertial coasting to maintain the performance as long as possible without the use of GPS signal. And at the point where the performance is too degraded, the flight management system will switch from the coasting inertial to the use of IRS with DME or VOR DME or pure IRS.
Thank you, Laurent. I'm taking the next one. On A350, if GNSS is deselected, does it lead to a MMR lock if the selection lasts over 1 hour?
So that I can answer this one. Did you hear me? Yes. So there is first, there is no link from the GNSS deselection and the MMR log. These are two independent facts. GNSS deselection will only affect the use of the GNSS inputs in the aircraft position computation. So the MMR can be logged completely apart. Maybe the question is more related to the GNSS deselection and the ADRU latch. If this is the case, I confirm that GNSS deselection does not help avoiding this latch from happening. Actually, the GPS deselection for the ADRU is seen as a GNSS loss. So if you deselect the GNSS, the 1 hour counter is already counting, so it will not change anything on this in this case. And it will not prevent the MMR log.
Thank you, Laura. Coming back on the previous question, how will spoofing affect aircraft enabled with SBAS or GBAS functions?
Yeah, so I will take this one. So yeah, SBAS and GBAS function. So I remind SBAS and GBAS are augmentation system that augment GPS position. So for SBAS and GBAS, especially SBAS is using the same frequency carrier of GPS. Therefore, if SBAS is affected, and it would affect SLS function, for instance, or GBAS is affected, it would affect GLS function. It will also affect the GPS pure position, but then it would affect GPS data as well. And so the detection mechanism that we have shown earlier will be successful, as it would be detected by the ADS part. So far, we have not observed such events in the field.
Thank you, Laurent. The next question is undue toes alert. Regarding the undue toes alert, sorry, do we have to expect inverse effects where real alerts are not generated because of erroneous GNSS position data?
So I can maybe take this one. So if there is an erroneous lateral or vertical position, we could not exclude this. However, please keep in mind that the GPWS basic modes remain available.
Thank you. Next question, could Airbus change the algorithm for toes not to rely on GPS altitude when GPS position is identified as spoofed and disregarded by IDS in order to avoid the fault-driven alerts?
I can take this one as well. So there are currently some studies about improvement of the TOS algorithms or TOS input use avoid these TOS alerts.
Can Airbus comment on events where effects of GPS jamming spoofing have remained after leaving an affected area and even remained on subsequent sectors? I think this one was regarding recent events that have